Good morning, student. I am Evan from JNU Shigao. Welcome you in the mathematics class. So today in the 10th class, our first topic is real number. So we will start with our first topic, real number. So before starting the real number, let us revise what we learned about the numbers. Okay? Before starting the real number, how many types of numbers we are knowing? Let us revise in short. So numbers. What numbers we are knowing? So we will start with the number first, prime number, whole number. What is whole number? All this we learned in our previous classes. Whole numbers means we will start from 0, 1, 2, 3 and go up to infinite. That is called whole number. Okay, that is whole number. Okay, so whole number include natural number. Okay, so natural number also we can take natural number. Natural number means that is start from 1, 2, 3 and so on. So what is the difference between natural number and whole number? Natural number start from 1 to 3 and goes up to infinite, and whole number is include 0. So that is natural number and whole number. Okay. So this is natural number and whole number. Okay. In whole number, natural number also coming. So that we will talk. After that we will talk about integers. What is integers? So integers include positive and negative number both. Okay. So positive, negative and 0. Or we can say negative number with whole number. So all the negative numbers minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Okay. So this is integer. So this is our number system. We start with the natural number, then we learn whole number, then integer. Integer is a combination of whole number and negative number. After integer, we learn about rational number. What is a rational number? Any number that can be written in the form of p by q. A number that can be written in the form of p by q. Okay, for example, 2 by 3, where q should not be equal to 0. So this type of number are called rational number, where numerator and denominator both will be an integer. So this is the example of rational number. Okay, students. So all this number system we already learned. Now after that, rational number. Now we are talking about irrational number. What is irrational number? So irrational number, if we will before talking about the irrational number, we should know what is irrational number. Irrational number means that can be written in the form of p by q, numerator and denominator, where denominator is not equal to 0. That is called irrational number. And to understand the irrational number, we will talk about the decimal expansion of the rational number. So what type of decimal behavior is shown by the rational number? So rational number is showing two types of decimal representation. That is called terminating and non-terminating but repeating. Non-terminating but repeating. So to understand properly the decimal behavior of rational number, we should know. Then we can easily understand what is the rational number. So two types of nature is represented by the rational number. That is terminating means when we will divide the numerator by denominator, it will terminate after a few steps and we will get the remainder 0. But if it is not terminating, but the some digit or the group of digit will repeat, so that is called non-terminating but repeating. So that is, for example, if we will take the example for 1.333 and so on. So this can be written as 1.3 bar. Okay. So this represents that this 3 is coming continuously. This process is never ending. So this type of numbers are also we are including in rational number. Then what is irrational number? So irrational number is the number when we divide, it will be non-terminating and non-repeating. Okay. Here non-terminating but repeating. But irrational number is which type of number? That is non-terminating and non-repeating. So if we will talk about the examples of this, so we can take examples for 1.10, 100, 100, and so on. So we can observe here the numbers or group of numbers are not repeating, but it is not terminating also. So this type of numbers are coming in irrational number. Okay, or another example we can take root 2, which is not perfect square, root 3, root 5, okay, even pi also. All these numbers, the value of pi, that is 3.14. So it is by supercomputer we could not find out whether the group of digits is repeating or not repeating in pi. We already obtained up to 1 lakh digit after the decimal in case of pi, but still the mathematicians are not sure whether it is a terminating after 1 lakh place also. So we are still keeping in the irrational number pi. So this is all these numbers we already learned on our previous classes up to 9th class. Okay, natural number, whole number, integer, rational and irrational. Then what is real number? So real number is a group of all this. Okay, it is set of all this. So that is called real number. So in real number, all these numbers are common. So that is, we can say this is the set of all these numbers is real number. So in real number, rational and irrationals are coming. In rational, integer, whole number and natural numbers are coming. So before starting the chapter, we should talk about what is real number. Okay, so this is about the number system which we already started from the 6th class, and gradually we are learning natural, then whole, then integer, then their basic operation plus, minus, and divide. Okay, so in 10th class, what topic we will discuss? So that was the short revision of real number, our number system. Now our first topic in the 10th class is Euclid division lemma. What is this Euclid division lemma? So let us talk about the Euclid division lemma. So our second topic is Euclid division lemma under real number. So Euclid division lemma we are using for finding the HCF of two numbers. What is Euclid division lemma? Okay, student, our next topic is first topic real number. Then the first topic under this is Euclid's division lemma. What is lemma? So Euclid division lemma. Why it is called Euclid division lemma, and what is the statement of Euclid division lemma? Actually, that is, this relation is based on the division process. Division process means when we are dividing one number by another number. For example, if we are dividing 3 by 2, okay. So let us see, if we will divide 3 by 2, so it will be like this: 3 divided by 2, 2 ones are 2, and 1 will remain. Okay, like this. And we know that this is our remainder. Sorry, this is our quotient. This is our remainder. This is our divisor, and this is our dividend. Okay, so that is the procedure. So we can write 3 is equal to 2, or we can write dividend is equal to divisor into quotient plus remainder. So our Euclid division lemma is based on this relation, where dividend, the number which we are going to divide, divisor by which we are going to divide, how many times it will go? It will go one time, and what will be the remainder? You go. Okay, so that is the relation. This relation is known by Euclid division lemma. This relation was perhaps known by earlier, but why the name is given Euclid division lemma? Because first this relation was discussed by Euclid in the 7th book of Euclid Elements. That is why the name to this relation is given Euclid division lemma. What is the meaning of lemma? Theorem we already know. 9th class also we learned what is theorem. So now I am telling you what is the meaning of lemma here. The lemma means already proven statement which is already proved. That statement we are using to prove another statement. So that is called lemma. So in this way, this is the explanation of Euclid division lemma, why this name is given. And what is the statement of this? Now let us see. The Euclid division lemma is related with this statement. For any two positive integers, for any two positive integers, they will exist unique integers such that a is equal to b2 plus r. So here a and b, we are taken to integer. Here a and b are any two integers. Okay, so we can take any two integers. So for any two positive integers, they will exist unique integers such that, means for if we will take any two integers a and b, so they will exist another two integers, that is q and r, in such a way so that they will satisfy this situation, that is a is equal to bq plus r, where r is greater than or equal to 0, but it is always less than b. That is the statement. This is the statement given by Euclid. If we are talking about any two positive integers, so they will have two, so there will be existence of two another positive integer in such a way so that the value of r is always greater than or equal to 0, but it is less than b. So this statement is known by the Euclid division lemma, and that is a very useful statement that we are using to compute the HCF of any two positive numbers, whether it is small or bigger, doesn't matter. By this method we can easily find out the HCF. To find out the HCF, the old method or traditional method, you already aware about it. Now in the 10th class, we will see how to find out the HCF of two numbers by using the Euclid division lemma. Before that, this relation we will prove. Okay, let us take two integers. Any two integers, I am taking two integers. So any two integers, suppose you are taking 24 and I am taking 7. Okay, these are the two positive integers. So which will be a and which will be b? A is equal to bq plus r. So this is the two positive integers. So which one is a bigger? That will be your a and the smaller number will be b. It means this bigger number will be your dividend and the smaller number will be your divisor. So with the divisor, if we will divide, so it will go 3 times 7 3 is 21. And how much will remain? That will remain 3 will remain. Okay, so 24 and 7. This was the two positive integers which was taken, and these two positive integers again they are the two another positive integers 3 and 3. Okay, so in this way we can define this relationship. And what is r? R is 3 here. This is your r, this is your q, this is your a, and this is your b. So a is equal to b2 plus r. Okay, so if we will multiply, 7 3 is 21 plus 3 24. So in this way, two integers we can define by using the Euclid division lemma. And the value of r, what is the possible values of r? R can be equal to 0. R can be equal to 0 or more than 0, but it is always less than b. Means the possible values of r here. Okay, the possible values of r will be 0, 1, 2, 3, 4, 5, 6. Any values of r can be from 0 to 6 because it is always less than b. So this is the explanation of statement. Now we will see how to use Euclid division lemma to compute the HCF of two positive numbers. So let us see. Euclid division lemma to find HCF of two numbers. first we are taking two numbers. Find HCF of 455 and 42 by Euclid division lemma. Okay. So now we will find out the HCF of these two numbers by using the Euclid division lemma. So HCF means highest number by which highest positive number by which we can divide both the numbers. That is the HCF of these two numbers. So how we will obtain by using this division lemma? So by Euclid division lemma, if we will start. So what we will do? The statement of Euclid division lemma is A is equal to BQ plus R. This is the statement of Euclid division lemma. So what I told you, the bigger number we will take A out of the given number. These numbers are given to us 455 and 42. So bigger number we will take A and the smaller number we will take B. So put in place of A 455 and in place of B, that is 42. Okay, now you try to divide. 455 is divisible by 42. Approx how many times? If we will take 10 times, so 42 into 10 will be 420. And if we will take 11 times, it will be more. So we will take 10 times. 42 times are 420. How much will be left? So it will left 35. Okay. So let us see. We define this two positive integer by Euclid division lemma. Now what you will do, if we are not getting the remainder 0, so we will continue this Euclid division lemma by taking the divisor and remainder. For the next stage, this 42 will be your A and this 35 will be your B. Okay. For the next stage, 42 will be your A and 35 will be your B. So these two we will consider divisor and remainder for the next step and we will continue. So 35, in the 35 how many times it will divide? It will go one time. 35 and 35. How much will remain? 7 will remain. So again you see it is not over. It will not over unless and until we are not getting 0 in the remainder place. So we will continue. So again we will continue by taking the divisor and remainder. For the next step, 35 will be your A. 35 will be your A and 7 will be your B. Okay. So in 35, the table of 7, how many times it will go? It will go 7 times 35 and what we will get remainder? We will get remainder 0. Okay. 7 times 35 and remainder will be 0. So in the stage, here we are getting remainder 0. Okay. This is remainder. So where we are getting the remainder 0, in that stage, the value of divisor will be the quotient. So this is the value of divisor. Okay. So the state in which we got remainder 0. We got remainder 0. So in that state, divisor will be HCF. Divisor will be HCF. So this is your HCF. So we can say the HCF for 455 and 42 will be how much? The HCF of 455 and 42 will be 7. So once again I will explain you. Okay. Here we are finding the HCF of two positive number using Euclid division lemma. So what is the statement of Euclid division lemma? A is equal to BQ plus R. What is A? What is B? So A will be the bigger number, greatest number among the given number, between the given numbers. So 455 we are taken in place of A and in place of B. B means divisor, 42. This is our dividend, this is our divisor. 455 we will divide by 42, it will go 10 times. And what will be the remainder? Remainder will be 35. Okay. So in this way we will start the question. In the next step, if we are not getting remainder 0, so we will continue by taking the divisor and remainder in the next step. So divisor will be A in the next step and the remainder will be B in the next step. You see, this will come here and this will come here. That will come in place of A and this will come in the place of B. And again we will continue. So 35 we will divide by 42. So with 35, 42 will be divided by 1 time and 7 will be remainder. Here again we are not getting the remainder 0. So again we will continue by taking the divisor and remainder. Okay, so our divisor is 35 and remainder is 7. Again we will continue. So with 7 if we will divide by 35, it will goes 5 times and here we are getting the remainder 0. So in the first, second and third step we are getting the remainder 0. Okay, that is doesn't matter in how many number of steps we are getting the remainder 0. But in particular step in which we are getting the remainder 0, in that particular step, what is the divisor? That will be the LCM of given two number. So in this step where remainder is 0, here the divisor is 7. So that divisor where the remainder is 0, that is the LCM of these two numbers. So this is the process. One more example I will solve to clear your concept. Let us see. So again, HCF of two number by Euclid division leema. Okay, HCF of these two numbers by Euclid division leema we are going to find out. So again we will start. What is the Euclid division leema? By Euclid division leema, the statement is A is equal to BQ plus R. What is A? Again, the bigger number between the given number. So that will be our A, that is 12,576. What is our B? B will be the smaller number from the given numbers we will take. Okay. So in this way we will decide A and B. Which one will be bigger? That will be your A. Which one will be smaller? That will be B. Now you divide. How many times it will go? So 12,000. Now let us see. This is 4,000. This is 12,000. So approximately 3 times it will go. So when we will multiply by 3, 4,152. So we will do it here. 4,052 3 times. So it will come 12,156. Okay. So that we will subtract 12,576 minus 12,156. Okay. So it will come 420. Okay. The table of 4,052, it will go 3 times and what will be the remainder? So remainder will be 420. Here we are not getting the remainder 0. When we are dividing 12,576 by 4,052, 3 times we are dividing this number by 4,052. So we are getting the remainder 420. That is not equal to 0. So we will continue with again taking the divisor and remainder in the next step. So in the next step, 4,052 will be value of A and 420 will be the value of B. Okay, the new value of A and B for the new step. Again you will divide. How many times it will go? If we will multiply 4 by 420, how many times? If we will do 10 times, so it will be 4,200, which will be more than that. So it will go 9 times. So let us see if it will go 9 times, how much it will come? 420 into 9. That is 3,780. So let us subtract 3,780. Okay, 2, 15 minus 8, 7, that is 10 minus 7 or 9 minus 7. So 9 minus 7 we will get 2 and here 0, 272. So here we will get 272. 452 will be your A and 420 will be your B. So when we will divide it, it goes 9 times. And what will be your remainder? 272, which is not equal to 0. Again we will continue. By taking the divisor and remainder. So 420 will be your new value of A and 272 will be your new value of B. So let us multiply. How many times it goes now? So it is, see, if you will multiply 2 times, it will be more than 500, and here is only 420. It will go only 1 time. So how much will be the remainder? 420 minus 272. Okay, so that will be 8, 11 minus 7, 4, 3 minus 2, 148. Look at here, that will be 148, it will go 1 time. Again it is not 0, remainder is not 0, again this process will continue. So that is 272 is divided by 148, how many times it will go? Again it will go 1 time. So it will go 1 time, and how much we will get? We will get 124. Okay, this step again we will continue because we are not getting the remainder 0. So I am writing here. So that will be 148. You will divide by 124. How many times it will go? Obviously it will go 1 time. And what will be your remainder? Your remainder will be 24. Okay. Your remainder will be 24. So again we will continue with divisor and remainder. So that will be 124 is divided by 24. How many times it will go? Can you guess? So it will go 5 times. And how much will be left? It will left 4. Okay. So again we will continue in the same process. 24. Okay, and 4. 4 6 are 24. And here we are getting the remainder 0. See. So we started, and after few steps we are getting here remainder 0. So the step in which you are getting remainder 0, in that particular step, what is the value of B? Okay, A is equal to BQ plus R. The step in which you are getting remainder 0, in that step what is the value of B? So the value of B is 4. So that is why HCF of these two numbers, that is 12,576 and 4052, that is 4. The HCF of these two numbers will come 4. So in this way we can find out the HCF of any two numbers, whether it is bigger or small, doesn't matter. Easily by Euclid division lemma we can obtain the HCF of two numbers. So I think you understand, and now you try to solve the textbook question by using the Euclid division lemma. So I am giving you two questions to try by follow this method, and if you have any doubt you can ask also. So students, you try find HCF by Euclid division lemma. Okay, so just this two question you just try it and send your answer by WhatsApp. Okay, so to find the HCF of these two numbers, okay student, you just try it, what we learn. So by solving this question you will be feel confident if you are getting your answer, and you send your feedback, your answers by WhatsApp, and if you have any doubt in any step, that also you can ask. Okay student, thank you, have a nice day.